All right, guys, let's look at how to state hypotheses. The way that you state hypothesis is important for two main reasons. The first one is that it allows you to identify, to determine what the conclusion is going to be, but also it allows you to select the type of test that you need to run. Let's look at some examples to see how to state hypotheses. In this one example, a gas station owner is concerned about the gas pump not dispensing the legal volume of 1 gallon for each gallon registered at the pump. All right, so that's the problem right there. Let's look at how to state the null hypothesis, which is also at times indicated with the letters HO or H0. You need to think of the null hypothesis as how things normally are, the status quo, the true parameter, okay? So now if you look at the question, at the problem, the way that the problem was stated, you will expect that things normally are the true parameter, basically any time that the gas pump will be exactly the legal value of 1 gallon, okay? So the null hypothesis in this specific case problem is that the gas value should be 1 gallon. Now, the alternative hypothesis, you need to think of it as the question of interest, okay? And again, you need to formulate the alternative hypothesis giving hints that you get from the way that the question was formulated. So in this specific problem, if you look at the problem, the gas owner is concerned that the gas pumps are not dispensing the legal volume. In this case, the alternative hypothesis then is that the gas volume is different from 1 gallon. Okay, this is important because the owner might be concerned that you are giving too little gas, in which case you could potentially get a fine from the government, or maybe you are just giving too much gas, in which case you are wasting money. When you get these kind of problems in which the alternative hypothesis is stated as different than, you will be using what is called a two-tailed test. Basically, when you look at a distribution, you will be interested to see if your sample data is on the extreme low or the extreme highest parts of that population, okay? Let's look at another example. The average yearly temperature in Hawaii is 25.5 degrees, and a scientist is concerned that the recent temperatures are becoming hotter. So again, if we look at the null hypothesis, which is how things normally are, from the way that the question was formulated, should be then that the temperature in Hawaii is equal to 25.5 degrees. The alternative hypothesis, which again is always what we are interested on, you need to also get a hint from the question itself, right? So in this case, if you look at the question, the way that it was formulated, the scientist is concerned that the temperatures are becoming hotter, right? So that means that the alternative hypothesis for this specific problem has to be that the temperature in Hawaii is larger than 25.5. At times, you need to be comprehensive in the way that you state this hypothesis. And another thing that is important for you to know is that the null hypothesis is everything that the alternative hypothesis is not. So in this case, since the alternative hypothesis is that the temperature is larger than 25, that means that the null hypothesis then has to include also cases when the temperature is less than 25. Again, not necessarily you are going to get that from the problem, but you can infer that from the alternative hypothesis. Again, the alternative hypothesis is everything that the null hypothesis is not. In these kind of problems, when the alternative hypothesis is basically interested on looking on cases that are greater than, you will be using what is called a right-sided test. Again, when you look at a population, you are interested to see what is the largest individuals on that population. Again, because the alternative hypothesis is asking where the specific sample is greater than. Now, let's look at this other example here. A company has advertised that their light bulbs last 8,000 hours, but has received numerous complaints from customers that the light bulbs last much less. The null hypothesis, which is again how things normally are, given this specific problem, should be then that the light bulbs last 8,000 hours, right? Now, the alternative hypothesis is always what we are interested on. And in this specific case, if you look at the problem, that the way the way that the problem was stated, is asking that the light bulbs are lasting much less. So that means that the alternative hypothesis has to be that the light bulbs last less than 8,000 hours. And given the fact that the null hypothesis is always everything that the alternative hypothesis is not, that means that you can further describe better this hypothesis by including case examples in the null hypothesis when the light bulb lasts more than 8,000 hours. Not that is indicated on the question, but again, for the purpose of you displaying the entire set of possibilities, you need to include in the null hypothesis cases where the light bulbs last 8,000 hours. In this specific case, when the alternative hypothesis is interested on cases where the parameter is less than, you will be using what is called a less-sided test. In this specific case, you are interested on examples that are less than the smallest individuals in that population, and that is normally what requires what is called a left-sided test. Let's review very quickly. Again, anytime that the alternative hypothesis is asking whether a given parameter is less than, you will be using a left-sided test. You are looking at the smallest individuals of the population. In cases where the alternative hypothesis is formulated in a way that the given parameter is greater than, you will be then looking at right-sided tests. Again, you are now looking at the largest individuals of that population. Alternatively, in cases when the given parameter is simply formulated as being different in the alternative hypothesis, you will be looking at what is called a two-tailed test. Basically, you will be interested on case examples where the population the samples are too small or too large. And that right there is how the hypotheses are stated. It's important for you to understand, to read the problem the way that is stated, because that will determine the way that you state the hypothesis. Critically, you need to always look at how state the alternative hypothesis, as that normally you get hints from that from the question itself. And once you set up the alternative hypothesis, anything that is not in the alternative hypothesis becomes what the null hypothesis is. All right, guys, I hope that's clear.